Hey guys, Mr. Bowman here. Today's learning objective is in pink and we're learning to identify the angle properties in relation to triangles. So during this video, we're going to be discussing 4 types of triangles and we're going to be going over the properties of each of those triangles, including how to use the properties to solve questions in relation to geometry or in relation to angles. So we're going to be switching pens back and forth a little bit again in this video, but the 4 types of triangles. Well, the first triangle we're going to look at, it's a right-angled triangle. So that one, the name does give it away, and the name does explain it quite a bit. And then we're going to move on to equilateral triangles. And that there is one of the simpler types of triangles. We're then going to shift over to isosceles triangles. Oh, I've spelled that wrong. Isosceles triangles. And then finally, we're going to have a look at the last type of triangle, scalene triangles. So we do need to know about all 4, but specifically, we do need to know about the angle properties of isosceles triangles because they are quite useful to solve problems, and there will be a little bit of usefulness for the equilateral triangle angle properties. So I suppose the beginning bit of information that's really critical and that's really important is that we've got a triangle, and all triangles will have 3 sides and it will have 3 angles. And those 3 angles will always sum to 180 degrees. So that's a geometric feature that we can use over and over again. And if we were to explain that in a sentence, I'll be writing the internal angles in a triangle sum to 180 degrees. So that's the geometric feature, or that reasoning, that I would basically be memorizing to justify any question in relation to a triangle. So that's the general concept. So there's 3 sides, 3 angles, they sum to 180. Let's specifically get into the different types of triangles. So a right angle triangle, the name does give it away. It is a triangle with a right angle in it. So I'm going to do an abbreviation. So it's a triangle with a right angle inside. And I'll get into this a little bit later on, but right angle triangles can also be, so I'll put some dash there, can also be isosceles triangles. So isosceles, and they can also be scalene triangles too. And as I said, we'll get into that a bit more. The next one, equilateral triangles. So I'm going to put a dash on each of those 3 lines, and these triangles have 3 equal sides, and inside the angles, because the sides are equal, they've got 3 equal angles. And we can actually mathematically figure out what the angle is. So if they've got 3 angles, so let's denote all of those angles as x, because they're mathematically the same. Those 3 x's should be adding up to 180 degrees, as we said before. So 3x should be equal to 180 degrees. So x would be 180 divided by 3. So x is always equal to 60 degrees. So those 3 equal angles, well, those angles, no matter what, are always going to be 60 degrees. So let's rub out those x's. and let's put those into our diagram. So regardless of the equilateral triangle, we're always going to have three equal 60-degree angles. Isosceles triangles, now these are the more useful ones. They are sides, or they are triangles. So let's have a look. Draw one, draw another side, where there are two equal sides. So two equal sides, which means there will be two equal angles. And what I'll write down is it's always the base angles of that isosceles triangles. So base angles. So if our triangle, this here would be the base, if the two equal sides sit along the top of that triangle. So the base angles are the angles that sit on the base of that triangle if it's got that orientation. So those two there are always actually equal to each other. And you can use that property quite often to solve problems. So we'll go through one example. If we know this top angle here, let's say we know that's going to be 100 degrees. Well, we know that the two x's from the base plus that 100, we know that that's got to be equal to 180 degrees because of our triangle rule. So we can actually use a bit of algebra to find out what each of those base angles are. So those x's, they would actually be 40 degrees each. And similarly, if we know one of the base angles, we can actually find out all of the angles about that triangle. So I'll show again what I mean by that. I'll get rid of our last diagram, our last working. But if you know, say this one here is 45 degrees, straight away, we know that the other angle is 45 degrees. So we'll call that angle A and we call that angle B. So if we were working on this problem, we would be able to say, well, angle A, that's 45 degrees because base angles of an isosceles, I'm going to call it isotriangle, they're equal to each other. So that means we could put 45 in here, and that means we could then go away and figure out what angle B is up the top. So angle B, well, that means 45 plus 45 plus B. Well, we know all three of those should add up to 180. Those two add up to 90. So if we take away 180 minus that 90, that means we've been told that that there is actually a 90-degree angle. So that's a right angle, 90 degrees. And that's actually an example of when the isosceles triangle can become a right angle triangle in that very exact combination of angles. So isosceles triangles, lots of interesting geometric features, including another kind of hidden angle geometric reasoning that you can use. Base angles of an isosceles triangle are equal. Okay, awesome. I'm going to get rid of that there just to make the video look a bit tidier. And the final one we're going to look at are scalene triangles. And scalene triangles are a bit harder to draw. And key thing is, I'm not putting any marks on the sides of these triangles because there are no equal sides. And if there are no equal sides, there are going to be no equal angles. And what that means is there's no, other than the generic rule about internal angles summing up to 180 degrees, there's no real angle properties that we can be aware of. So I'll go through a couple examples. So to solve these problems, so let's say that there is 30 degrees. Oh no, that's too small, too big to be 30 degrees. So let's say that there is 70 degrees and that angle there is 30 degrees. We can use the 180 degree rule to find out the missing angle of that scalene triangle. So we know that 100 plus x should have been equal to 180, which means x was equal to 100, which x was equal to 80 degrees. And the last thing about scalene triangles, if we change these numbers out a little bit, we actually get something quite interesting that we've looked at before. I won't give it away yet. So let's say we're going to try find angle y now. But let's say maybe this one here is 50 degrees and that one there is 40 degrees. So we know that 90 plus y is equal to 180. Y would be 90 degrees. So again, like in the isosceles triangle, it's possible for that to come up with a 90-degree angle, which links back to our statement before that scalene triangles can also be right angle triangles. So that was a very quick overview of the 4 types of triangles. We also went through and tried to identify the angle properties of each triangle. And we've gone through 2 geometric reasonings that we need to know. We need to know the internal angles of a triangle are equal. And we need to know that the base angles of an isosceles triangle are equal. Hopefully you found this video useful, guys. Thanks for watching.